Hello students, in this video we'll compute the determinant whose entries are the minimum and maximum of the row and column numbers. Let's compute determinant of A, where here A is the matrix Aij, I and j go from 1 to n, and here Aij is just going to be the minimum of I and j. All right, so let's do it. So what will our matrix look like? So we'll do a special case first. Let's do n equals 4. And n equals 4, we're asked to compute this determinant of just 1, 1, 1, 1, because the minimum of I and j, I'm in the first row, so the first row is at 1 will be the minimum. And then I'll have a 1 over here because I'm in the first column, but then a 2 over here, then a 2 over here, then a 2 over here, then a 1 over here, a 2 over here, a 3 over here, and then a 3 over here because I'm in the third row. A 1, 2, 3, and 4. So we can see there's lots of symmetry in this. And what we'll do with the minimum calculation is we're going to move along columns, right? And so I'm going to reduce this by saying this is the determinant first of. I'll leave the first column the same, second column the same, third column the same. But then I'm going to replace the fourth column with a column 4 minus column 3. That'll be a 0, a 0, a 0, and then a 1 over here, right? I'll do the same thing. I'll replace column 3 with column 3 minus column 2. So this is the determinant of 1, 1, 1, 2, 1, 2, and then a 1, 2, 1, 2. And then I'll have if I subtract the second column from the third column, I'll have a 0, 0, 1, 1, 0, 0, 1, 1, and then a 0, 0, 0, 1. And finally, I'll subtract off the first column from the second column, 1, 1, 1, 1. And then I'll have a 0, 1, 1, 1, 0, 0, 1, 1, 0, 0, 0, 1, like so. And now I have a subdiagonal matrix over here. I have a subtriangular matrix. So this is just the product of the entry, so I just get a determinant of equal to 1. Now, how would I generalize this idea? So if we have the n by n matrix, what can we see? So for the n by n matrix, in general, what will happen? The answer will still be 1 in general. In general, what do we have? We'll have the determinant of 1, 1, all down to 1, then 1, 2, all the way down to 2. Then the very, very last row, we'll have a 1, 2, 3, all the way down to n, right? And of course, what we'll do is if we subtract the n minus first column from the nth column, this will become determinant of 1, 1, 1, and then a 0 over here, a 0 over here, and then a 1, 2, down to 2, and then a what? And then a 0 over here, right? Bearing in mind that this over here will be an n minus 1, right? All the way down to 1, 2, 3, all the way down to n minus 1, like that. And then what? And then we'll have a 1 over here, right? Excellent. Okay, that's great, because now right above it, what's going to happen over here? So we notice that right above it, in that last entry, we're also going to have an n minus 1 over there, like so, in that last entry over there, because the minimum is going to be n minus 1. And so now what we have is if we expand along this last row over here, we see that they will get exactly the same pattern. So by induction, I can just keep subtracting, subtracting. And if we do this over and over and over again, we're just going to get to the determinant of what? Of just something that looks of this form over here, just a whole bunch of 1s on the main diagonal. So 1, 0, 0, 0, and then a 1, 1, 0, 0, 1, 1, 1, all the way down to 0, and finally a 1, 1, 1 on the main diagonal down to finally a 1. And so the determinant in this case is equal to 1. So for any n, the determinant of the minimum matrix is equal to 1. Excellent. Now the maximum is a little bit different. So let's figure out how the maximum works. And so for the maximum, let's compute the determinant, compute B, determinant of B. And what's B? So over here, B is Bij. I and j go from 1 to n. And Bij is just the maximum of I and j. Okay? And so how we're going to do this one over here, so let's again look at n equals 4 to see how we're going to proceed with this. So if n is equal to 4, what's going to happen? We're going to have determinants of the matrix what? The maximum is going to be a 1, 2, 3, 4. Then a 2, 2, 3, 4. Then a 3, 3, 3, 4. Then a 4, 4, 4, 4. Okay? Excellent. So now we're going to do work by rows. The determinant 1, 2, 3, 4, 2, 2, 3, 4, 3, 3, 3, 4. Then subtract the third row from the fourth row. This is going to turn into a 1, 1, 1, 0 like that. Excellent. Then I'm going to subtract the second row from the third row. 1, 2, 3, 4, and then 2, 2, 3, 4, and then 1, 1, 0, 0, like that. And then a 1, 1, 1, 0, like so. And then finally, last step over here is to compute the determinant, then do the last row over here. The last row is going to be 1, 2, 3, 4, and then a 1, 0, 0, 0, 1, 1, 0, 0, and then 1, 1, 1, 0 like this. You might say, well, how does that help me over here? Well, now what we can do is we can expand along this last column over here, right? So I can get a plus, minus, and we see now that the degree of n, the parity of n, will come into the formula. So this is a minus 4 times what determinant? It's going to be minus 4 times this 1, 1, 1 determinant. So this answer over here is just going to be negative 4. So that determinant is going to be negative 4 in the 4 case. And so, of course, what we'll see now is if we have the general case, what will happen is in general, we're going to have determinants of what? Of the first row, you're going to have a 1, 2, 3 up to n. Then we're going to have a 2, 3, 2, 3, excuse me, we'll have a 2, 3, 2, 2. So let's get that out of the way. So 2, 2. The next one's going to be 2 there. 2, 2. Then the 3 over here, all the way down to n, like so. Then we'll have 3 3s, 3, 3, 4, all the way down to n. And finally, the last row is just going to be what? All n. And by subsequently subtracting from each row from the row n-1 from row n, n-2 from n-1, et cetera, et cetera, et cetera, we're going to reduce it to, after a finite number of steps, to the determinant of just 1, 2, 3. The first row stays the same through this whole process. And then we'll have a subdiagonal matrix over here for the minors that's left over. And then we'll have a 1, 1, 1. 1, 1 over here. That's going to be a 0 actually. So that's going to be a 0. And that's going to be a 0 over here. And then a whole bunch of zeros. Then all the way down to 1, 1, 1. And then finally a 0 down over there. And now if we expand along here, what we're going to see, this is going to be a negative 1 to the n-1. So this is going to be a negative 1 to the n-1 for the sign of the determinant. And then n itself. And then times that subdeterminant. Well, the subdeterminant is going to have 1 in the main diagonal, so this is going to be the formula in general. So that's the formula for this determinant in general. So the determinant of B is negative 1 to the n-1 times n. And if we plug in, for example, n equals 4, we have a 4 and then a negative 1. So indeed, it works out with this case when n is equal to 4. So this is the general methodology. You just subtract every row from the row above it, and it will turn into a lower triangular matrix times one element on the very, very top right corner. And that will figure out the way of computing B's determinant when B is the maximum of the row and the column number. And then similarly, doing by column operations, we can compute the formula for the determinant of the minimum of the row and the column number. Thank you very much.